All right, let's just get right into it. If you've ever tried to build an AI agent, I'm willing to bet you've done this exact thing. You've written a massive, like 400-line system prompt, right? You just cram everything you can think of in there. Library rules, how it should sound, QA policies, output formats, you name it, it's in this one giant text file. And let's be honest, it probably doesn't work that great. Well, today we're going to fix that. See, with that giant monolithic prompt, you're not actually creating a powerful agent. What you're creating is, well, an anxious intern. It's like you're handing it a PhD thesis worth of information and then asking it to answer a simple email. It gets completely overwhelmed, it ignores most of what you told it, and it ends up giving you the wrong output anyway. And that really gets to the heart of the problem. The core mistake, the architectural flaw, is that we're trying to load all the knowledge up front. What we really need is a way to give the agent knowledge just in time, right when it needs it and not a moment sooner. So in this explainer, we're going to break down 5 super powerful design patterns from Google's research and their agent development kit, the ADK, that solve this exact problem. But before we can even get to the patterns, we have to talk about their fundamental building block. It's a concept Google calls a skill, and you'll often see it as a file just named skill.md. So what is a skill? The easiest way to think about it is like a microservice, but for your agent's behavior. It's this neat, self-contained little package of instructions. But here's the really brilliant part. It has this 2-layer structure. The first layer is just some lightweight metadata, basically for discovery, so the agent knows it exists. It's only when that skill actually gets triggered that the agent loads the second layer, the actual step-by-step instructions. This whole idea is called progressive disclosure, and it's the absolute key to getting rid of that bloated context. All right, let's build on that with our very first pattern. This one's the simplest and probably the most common you'll see, the tool wrapper. You've definitely seen this problem before, right? Your agent tries to call a library's API, but it gets it wrong because it doesn't know some specific convention. The old way was to just stuff the documentation into the system prompt. The tool wrapper fixes this by creating a skill that loads those conventions only when the agent decides to use that tool. It's a brilliant way to turn your agent into a fast API expert on demand, without bloating the context all the time.
Okay, pattern number 2 is the generator. And this one is all about getting some consistency in your agent's output.
You know the feeling. One day your agent gives you a perfectly formatted report, and the next day, it's a total mess. The generator pattern solves this by separating 2 big concerns. You have a style guide that dictates how to write, the tone, the formatting, and then you have a template that dictates what to produce, the actual structure of the report. The agent's only job is to coordinate the 2, which means you get predictable, high-quality output every single time.
Moving on to pattern 3, the reviewer. This is where things start to get really surgical, really policy-driven. Vague feedback like, yeah, that looks good, is totally useless for an agent. The reviewer pattern fixes this by separating the review protocol, that's the process of how to do a review, from the actual review checklist. And the key insight here is that the checklist is completely swappable. You can swap out a Python checklist for, say, an OWASP security checklist, and boom, your code reviewer is now a security auditor. Same infrastructure, totally different policy. It's incredibly powerful.
Let's talk about pattern 4 inversion. Now, this one is often overlooked, but for production systems, it is absolutely critical.
Agents, by their nature, are just a little too eager to please. They'll take a vague request and immediately try to fill in the blanks with assumptions, which, of course, are almost always wrong. Inversion flips that dynamic on its head. Now the agent drives the conversation. It basically interviews you, the user, through these gated phases. It has to get through phase 1 and phase 2, gathering all the necessary details before that lock opens and it's allowed to generate anything. This totally prevents that premature generation and makes sure the final output is what you actually wanted. And that brings us to our last and probably most complex pattern, the pipeline. This one is all about enforcing those strict, multi-step workflows. Here's a classic problem. Your agent sees the final goal and it just jumps straight to it, skipping a really important validation or QA step along the way. The pipeline pattern makes that impossible. It forces a strict sequence with explicit gates. The agent literally cannot move on to editing a document until the user has confirmed the initial search results. There are no shortcuts, no skipping steps. Period. So there you have it, our 5 patterns. But the real power, the true 10x leverage, kicks in when you realize these aren't meant to be used alone. They are designed to be composed, to be stacked together. And this is where it all just clicks into place.
You can have a pipeline that calls a reviewer skill to QA its own work, or a generator that uses the inversion pattern to gather all the variables it needs before it fills out its template. In fact, a recent study on Archive found that real-world production systems use a median of 2 patterns per skill. For complex tasks, you almost never ship a skill with just a single pattern.
Now, this is all cool from an architecture perspective, but let's talk about the one thing that really matters when you're at scale: the cost.
Okay, just look at this. That monolithic prompt, the one with, say, 8,000 tokens. Well, you're loading that on every single request. And that gets expensive, and it gets expensive fast. We're talking 10,000 requests a day, you're suddenly looking at around $40. But with this modular, skill-based approach, you're only loading the small bit of context you actually need, maybe 1,200 tokens. And just like that, your daily cost plummets to just $6.
The numbers really speak for themselves here. That's an 85% reduction in your context cost. And you get that while also getting better, more reliable behavior from your agent. This is exactly why these architectural patterns aren't just some academic exercise. It's about pure economics.
So, this is it. This is the whole map. It's not just a random list of 5 ideas. It's a complete, cohesive, and composable toolkit for building AI agents that are robust, efficient, and most importantly, cost-effective. So the big takeaway here is really simple. Stop writing those giant monolithic prompts. Start building with patterns. Take a hard look at your own agent code and ask yourself, which one of these 5 patterns are you going to implement first?